What's going on, guys? Let's look at this problem right here. Here this question is asking, let xy belongs to a natural number, determine if the following statements are true or false. So first one is asking, for all x there exists a y such that x minus y is equal to 0. Is this true or not? Now for all x, for example, let's say x is 1 and there exists a y that will make this one 0. So for example, if x is 1, if y is 1, that's going to be 0, and if x is 2, y is 2, that's going to be 0. So this is true. So this one is true. Example is y is equal to x. If y is equal to x, this is always going to be true. Now let's look at the second statement. For all x there exists a y such that 3x minus y is equal to 0. Now for example, let's say x is equal to 3. So 3 times 3 is 6. There exists a y. If you subtract 6, that's going to be 0. So, and another example, if you say 7, x is 7, 3 times 7, 21, minus 3 times 7, 21, minus there exists a y, it can be any number, 21, that is equal to 0. So we can say y is equal to 3x in that way, like whatever the multiplier, for example, we took 7 here, x is 7, 3 times 7, 21. So 21 is the y, right? Y is equal to 3 times of 7. So whenever we have this kind of situation, this is always going to be true. So this is true. Now let's look at the third situation. For all x, there exists a y such that x minus 3y is equal to 0. You may tend to go and say this is true as we seen before, but this is a little bit different. Like for example, if we say x is 3, there exists a y, like if you multiply this one by 1, 3 times 1, that's going to be just 3. So 3 minus 3, that's going to be 0. That's correct. But what if this is 1? If x is 1, 1 minus 3 times, if it's 1 over 3, it's true. But here they have mentioned this is x and y belongs to a natural number. So it can be 0, 1, 2, 3, 4, 5. It cannot be a decimal number, right? So this is not true. Like this one is not true because for x is equal to 1, this is not true. So false. Example, when x is equal to 1. Now let's look at the D part. There exists an x and there exists a y such that x plus y is equal to 15. There are many different ways you can do that. For example, you can say x is equal to 5 and y is equal to 10, or you can say x is equal to 8 and y is equal to 7. So this is always true, right? So we can say this is true. Now let's look at the E part. E part is saying for all x is greater than 5 implies that for all y such that y is greater than x implies y is greater than 5. Okay, now let's it looks a little bit bigger, so let's break it down. Let's look at this one. For all x is greater than 5. X is greater than 5 mean what? X can be 6, 7, 8, 9, 10, something like that. So such implies for all y is greater than x. If y is greater than x, if x is greater than 5, 6, 7, 8, 9, 10. If y is greater than x, it means it starts from 7, 8, 9, 10. So if y is 7, 8, 9, 10, it implies that y is greater than 5. It's true because y is 7, 8, 9, 10. It means it's definitely greater than 5. So we can say this is true. Now let's look at the last one. The last one is saying for all x is greater than 5. It's similar to this one. Implies that for all y such that y is greater than x implies y is greater than 7. Okay. Let's break it down. X is greater than 5. It can be 6, 7, 8, 9, 10. Implies for all y is greater than x. If y is greater than x, it's going to start from 7, 8, 9, 10, right? Implies that y is greater than 7. But it's not true, but because y is greater than x mean it's starting from 7, 8, 9, 10. But greater than 7 means 7 is not included. So this is false. This can be true if they have put this sign, like greater than or equal to, then we will have 7 also included. In that way that might be true, but this is false as the question given. Okay, if we include this one, it's true, otherwise it's false. And that's how we do that. I hope this helps. Thanks for watching. And if you're trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.